Good day. We are now talking about electric field. But before that, let's review our previous lesson on electrostatic force. From our previous lesson, we learned that charged objects will repel if they have the same charge. In this case, we have two positively charged objects and they will repel. If both objects have opposite charges, positive and negative, they will attract. This force of attraction or repulsion involving charged objects is called the electric force or the electrostatic force, if we consider the case when they were both initially at rest. The strength of this force is described by the formula called Coulomb's law. This law states that the electrostatic force is directly proportional to the product of the charges and inversely proportional to the square of the distance of both objects. So, this Coulomb's law describes the forces that act at a distance between two charged objects. However, there is another way to describe this phenomenon. Instead of thinking about Coulomb's law, we can use the concept of an electric field in the following manner. Step 1. Think of one charge as producing an electric field everywhere in space. Step 2. The force on another charge introduced into the electric field of the first is caused by the electric field at the location of the introduced charge. Now, this new charge that we just introduced has a magnitude much smaller compared to the first charge. So although this new charge also produces its own electric field, the electric field that it produces is negligible compared to the electric field produced by the first charge. And so the influence of the first electric field is much stronger towards the second charge. And in fact, due to the presence of the electric field introduced by the first charge, the second charged object experiences a force which is given by the formula F equals QE, where small q is the charge of this new object and E is the magnitude or size or strength of the electric field produced by the first charge. So, consider a charged object Q, and we call this the source charge because it is the source of the electric field. Q produces an electric field everywhere in this space around it. Now, this electric field is normally represented as a bunch of arrows extending radially outward or inward, depending on the charge. So if Q is positive, then the electric field lines extend radially outward from the source. Radially outward from the source. So in this case, Q here is positive. However, if Q is negative, then the electric field lines point radially inward toward the source. This is based on a convention involving positive test charges. Now, if another object is introduced in the electric field of the first charge, we call that the test charge. And the charge of this new object, the test charge, is significantly much smaller than the first, or the source charge. So the test charge will feel a force of magnitude given by F equals QE, where where Q is the value of the charge in coulombs and E is the strength of the electric field, given by the SI units newtons per coulomb. So, the strength of the electric field depends on two factors. First, it depends on the charge of the source. The greater the value of the source charge, the greater the strength of the electric field it produces. Second, it depends on the distance of the point in space in consideration to the source charge. For example, if we have 2 points in space, point A is closer to point B, the strength of the electric field at point A is greater than at point B. You can see here in this GIF that the electric field detector detects the value of the electric field to grow smaller and smaller as it moves farther and farther away from the positive source. In fact, for source charges that are point objects or spherically symmetric charged objects, the strength of the electric field it produces at each point in space around it can be determined using the following equation, where Q is the charge of the source and R is the distance from the source to the point in consideration. It is important to note that even if there is no test charge around the source, the electric field still exists around the source charge. Once another charged object happens to pass by this electric field produced by the source charge, this test charge will feel an electric force as it interacts with the source charge via the electric field. So that's it for now. I hope you guys learned something today. Thank you very much. I don't care, and I'm with my baby.